Good morning. I'm Dr.S.Sharmila, Associate Professor and Head, Department of Industrial Biotechnology, Bath Institute of Higher Education and Research. Today I'm going to handle unit operations, and the topic is distillation. So distillation, what is distillation? It is the process in which the liquid or vapor mixture of two or more substances will be separated into its component with desired purity by the application of heat. So here the distillation is done on the basis of boiling point difference. So the main principle behind this distillation is separation of components from the liquid mixture based on the boiling point differences. So if the boiling point difference exists between the two liquids which are present in the mixture, then those liquids can be separated by means of distillation process. This distillation also depends on the vapor pressure characteristics of the liquid mixture. What are the applications of this distillation process? The distillation process is widely applied in many fields. First, it is mainly used for separating the volatile oils and also used for separating the drugs which are obtained from the plant and animal sources like vitamin A is extracted or separated from the fish liver oil. And the purification of organic solvents like absolute alcohol. So those can be purified by means of distillation process. And it is also used for purification of drugs which are obtained from the chemical process. And it is also mainly used in the production of distilled water or spirit of ammonia, spirit of nitrous ether, and it is also used in refineries. In refineries, refining of petroleum products like a petroleum ether 6080, and it is also used in the recovery of solvent synthesis. So there are wide application of distillation is available. This distillation can be classified into several methods based on the application or based on the principle of distillation. So we can classify this distillation into many categories. First is simple distillation. Simple distillation, or it can be otherwise called as differential distillation. And second one is flash distillation or equilibrium distillation. Third one is vacuum distillation, that is distillation under reduced pressure, which is called vacuum distillation. Then molecular distillation, like evaporation distillation, or it can otherwise called as short path distillation. The next one is fractional distillation, or it can be called as rectification. Then other classifications are azeotropic or extractive distillation, steam distillation, destructive distillation, compression distillation. First, simple distillation. So what is simple distillation? It is the process of converting a single constituent from a liquid mixture into its vapor. Then this vapor will be sent to the condenser where it will be condensed and we can get the purified liquid. And this process is also known as differential distillation, as distillation is based on the differences in the volatilities and the vapor pressures of the components in the mixture. So this is called simple distillation. The principle behind the simple distillation is the liquids when the liquid when the liquid boils, the vapor pressure of the liquid will become equal to its atmospheric pressure. So when the liquid will boil, the boiling will occur only when the vapor pressure of the liquid becomes equal to the atmospheric pressure. At that condition only, the liquid will start to boil. And this simple distillation is conducted at its boiling point. So the basic principle of distillation is boiling point only. The higher the relative volatility of a liquid, the better is the separation by simple distillation. That means the boiling point difference of the liquid compounds in the mixture should be more. Say, for example, if the two liquids which are considered liquid A and liquid B. Liquid A boiling point is say some 100 degrees Celsius, and liquid B boiling point is say some 300 degrees Celsius. So in this case, the boiling point difference between liquid A and liquid B is very high. That is 200 degrees Celsius. The difference in the boiling point of A and B is 200 degrees Celsius. So when we distill or when we separate these two compounds, first the liquid A will vaporize, will evaporate first. Then that vapor will be sent to the condenser. Then that condenser will convert this vapor into liquid A, so that we can separate liquid A and liquid B. So mostly this distillation will be useful only when the distillation or the boiling point of those compounds will be very high. Then only we can go for the simple distillation. And the heat is supplied to the liquid, so that since we are supplying the heat, the liquid will boil. The resulting vapor will be transferred to different place, and it will be condensed. So here the condenser plays an important role, which converts this vapor into the liquid. The construction of the simple distillation. So this simple distillation, it consists of a distillation flask with the side arm sloping downwards, and the condenser will be fitted into the side arm by means of a cap. The condenser is usually water condenser, because the water will be used as a coolant, that is jacketed. The water will be circulated through the jacket, so that the vapor will be condensed into the liquid. And the condenser is connected to a receiver flask, because once the vapor converts into the liquid, then that vapor has to be collected in a separate container. So there will be a receiver flask will be connected to the condenser using an adapter with ground glass joints. On the laboratory scale, the whole apparatus is made of glass. But if it comes in the industrial scale, then they will be using stainless steel for distillation. So this is the construction of simple distillation. So we have the flask, and the flask side arm is connected to the condenser, and the condensed liquid, there is the receiver flask where the condensed liquid is collected. So when the liquid mixture is fed into this flask, and the heat will be supplied to this flask, so that what happens, the low boiling liquid will evaporate first, and that vapor will be sent to the condenser. And since the condenser is having the cooling water, this vapor will be converted into the liquid, and the liquid will be collected in the receiving flask. So this is the simple construction of the simple distillation apparatus. So how it is working? So the liquid which has to be distilled is filled in the flask. 1/2 to 2/3 of its volume only has to be filled. If it is fully filled with liquid mixture, then it cannot, the liquid once the vapor starts boil, it may come out from the flask and it may enter into the condenser. So 1/2 to 2/3 of its volume of the flask will be filled with the liquid mixture, and bumping is avoided by adding small pieces of porcelain before distillation. So they'll be adding some porcelain material to avoid the bumping of the liquid. And the thermometer will be inserted to measure the temperature, and the thermometer bulb must be just below the level of the side, and the water will be circulated through the jacket to condense the vapor which is coming through the condenser. And these contents which are present in the flask will be heated gradually. And the liquid, when it begins to boil after some time, the vapor will start to rise up, and it will pass through the side arm into the condenser, and the temperature rises rapidly and reaches the constant value. The temperature of the distillate will be noted by means of the thermometer, and this will be equal to the boiling point of the liquid, because we already know that once boiling starts, then after boiling the vapor will be evaporated, then the vapor will be sent to the condenser. The vapor will be condensed and it will be collected into the receiver, and the flame will be adjusted so that the distillate is collected at the rate of 1 to 2 drops per second to collect the condenser, to collect into the condenser receiving flask. And this distillation should be continued until a small volume of liquid remains in the flask, because that liquid may be the second compound, which is having the higher boiling point. Next, flash distillation. So flash distillation is the simplest method of separation process, and it is defined as the process in which the entire liquid mixture will be suddenly vaporized. That means suddenly flashed by passing the feed from high pressure zone to the low pressure zone. The more volatile component will be concentrated in the vapor stream, and the less volatile compounds which are in the liquid that will be present in the liquid stream. And this flash distillation is also known as equilibrium distillation. That is, the separation is attempted when the liquid and vapor phases are in the equilibrium condition. This method is often carried out as a continuous process and does not involve rectification process. The principle behind this flash distillation is when a hot liquid mixture is allowed to enter from a high pressure zone into the low pressure zone, then the entire liquid mixture will be suddenly vaporized. So when in the previous simple distillation, we are taking both the liquid mixture into the flask at a time. But here what we are doing, first we are heating the liquid mixture, then that liquid mixture is suddenly it is flashed into the system from high pressure zone to the low pressure zone, so that the complete the liquid mixture will be suddenly it will be vaporized. So this process is known as flash vaporization. During this process, the chamber gets cooled. So the individual vapor phase molecules of high boiling fraction get condensed. So once sudden cooling starts, the vapor will be condensed and low boiling fractions will be remain as the vapor. So high boiling fractions, once the chamber gets cooled, high boiling fractions will be immediately it will be condensed, but low boiling fractions will be remain as such vapor. So this is the flash distillation apparatus. So here the feed is fed into this with high pressure. It is flashed. The feed initially it is at high temperature, and immediately it is flashed. It is sent to the chamber with high pressure to low pressure. Immediately when the pressure is reduced, pressure reducing valve is there. So initially it is pumped into this chamber at a high pressure, and suddenly once the pressure released, it will be sent to the here the chamber is provided. So once it suddenly it flashed into this chamber, the high boiling liquid fractions will be condensed and the low boiling liquid fractions will remain the vapor, so that we can separate the liquid mixtures. So the working principle of this flash distillation is, first the feed will be pumped through the heater at a certain pressure. Then the liquid mixture will be heated, which enters the vapor liquid separator through the pressure reducing valve. Due to the drop in pressure, so initially the liquid mixture is coming to high pressure, and suddenly since the pressure is reduced by means of pressure reducing valve, the hot liquid flashes which further enhances the vaporization process. The sudden vaporization induces the cooling. So since sudden vaporization is occurring here, so immediately the cooling will also be induced. The individual vapor phase molecule of high boiling fraction get condensed, while low boiling fractions will be remaining as the vapor. Then the mixture is allowed for sufficient time so that the vapor and the liquid portions will be separated from the equilibrium. So it will be separated to achieve the equilibrium, and the vapor is separated through a pipe from above, and liquid is collected from the bottom of the separator. By continuously feeding this into the still, it is possible to obtain continuous flash distillation. So the flash distillation can be maintained as a continuous process. The operating condition can be adjusted in such a way that the amount of feed exactly equals the amount of material released. Therefore, the vapor and the liquid concentrations at any point you check, that will be remain constant in the unit. So the uses, what are the uses of this flash distillation? So this flash distillation is used for separating the components which boil at wildly different temperatures, and it is also used in petroleum industry for refining the crude oil. So mainly in crude for refining the crude oil, this flash distillation only used. And the advantage of this flash distillation is it is a continuous process as we discussed earlier. So this is the continuous, this can be done as a continuous process. But in case of simple distillation, it is a batch process. And what are the disadvantage of this flash distillation? It is not an effective process in separating the components of comparable volatility. And it is not an efficient distillation when nearly pure components are required. When we need to purify the liquid, we cannot go for this flash distillation process because the condensed vapor and the residual liquid are very far from the pure. So we cannot we cannot get a highly purified liquid fraction by means of this flash distillation process. So the main advantages, it can be just a continuous process, and the main disadvantages, we cannot get a highly purified liquid. We cannot separate highly purified liquid from its mixture. Next is steam distillation. Steam distillation is a method of distillation which is carried out with aid of the steam. In previous simple distillation and all, we'll be using the heater. Here we are using the steam. It is used to separate high boiling substances from non-volatile impurities, and it is also used to separate immiscible liquids. It is a special type of distillation used for high heat sensitive material. So the steam distillation is, since we are using the steam, we can use it for separation of the heat sensitive material, because steam the temperature will be very it will not like normal heating, it will not be affecting the sensitivity of the material. So that's why this is mainly suitable for heat sensitive material. So the principle of this steam distillation is addition of water vapor lowers the boiling point of the liquid. So if you add the water vapor, which will lowers the boiling point of the liquid. So when the mixture of two immiscible liquid is heated, while being agitated to expose to the surface of each liquid to the vapor phase, each constituent independently exerts its own vapor pressure as a function of temperature, as if the other constituent were not present. Consequently, the vapor pressure of the whole system increases. So boiling begins when the sum of the vapor pressure of the two immiscible liquids just exceeds the atmospheric pressure. We know that when the boiling will start when the vapor pressure becomes equal to the atmospheric pressure. So here the sum of the liquids vapor pressure exceeds the atmospheric pressure, then the boiling will start. So in this way, many organic compounds insoluble in water can be purified at a temperature below the point at which decomposition occurs. So these compounds, which are like heat sensitive compounds, can be separated by means of this steam distillation process. So example, the boiling point of bromobenzene is 150 degrees Celsius and the boiling point of water is 100 degrees Celsius. But if both are present as a mixture, and that will boil at 95 degrees Celsius itself. So thus the bromobenzene can be easily distilled at a temperature 61 degrees Celsius. So but initially originally the boiling point is 150 degrees Celsius, but here it can be distilled at 61 degrees Celsius itself, which is below the boiling point of the bromobenzene. Then coming to the construction and working of this steam distillation, metallic stem can be fitted with the cork, which are having two holes, and the safety tube will be provided. It is inserted up here to the bottom through one hole and maintain the pressure inside the stem. And moreover, when steam comes out from safety tubes, which indicates that is empty, and through other hole, tube is passed, and the other end of this tube is connected to the flask, which is containing non-aqueous liquid in which the tube is dipped. The flask and the condenser is connected with the delivery tube. The condenser is connected to the receiver with the help of adapter, and the provisions are made to heat both the steam steam can and flask separate. So this is the steam distillation apparatus. So here the steam is generated by means of another liquid by means of water separately, and this steam is sent into this liquid mixture, which is going to be separated. Once the steam sent to this liquid mixture, already heating is also done, and steam is also supplied, so that the boiling point of the liquid mixture becomes reduced. So at the lower boiling point itself, one of the compound will be evaporated, and the evaporated compound will be sent to the condenser, where it will be condensed, and we can collect the condensed liquid by means of the receiver flask. So this is the working and construction of the steam distillation apparatus. And when coming to the applications of this steam distillation, it is mainly used in the manufacture of essential oils, which are used in the perfumes, and the steam is passed through the plant material containing desired oils, and it is also used in the eucalyptus oil and orange oil production and it is also used in the separating intermediate or final products during synthesis of complex organic compounds, and it is also used in the petroleum refineries and also petrochemical plants, and it is used to extract volatile oils like clove, anise, and eucalyptus oil, and it is used in the purification of essential oils like almond oil, and camphor is distilled by this method only. So the camphor is produced by this steam distillation method only, and aromatic water are also prepared by means of this steam distillation, because the aromatic nature of those particular compound will not be affected, because we are this is mainly used for heat sensitive materials. And the disadvantage of this steam distillation is it is not suitable when two immiscible liquids reacts with each other. If those two liquids are reacts each other, then at that condition we cannot use this process for separating those compounds. Next is azeotropic distillation. So before entering into this azeotropic distillation, we should know what is azeotropes. So azeotrope is a mixture of two or more liquids in such a ratio that its composition cannot be changed by a simple distillation. So it is the mixture of liquid. Azeotrope is nothing but the low boiling mixtures, and this will occur when an azeotrope is boiled. The resulting vapor has the same ratio of constants as the original mixture, and because their composition is unchanged by distillation, azeotropes are so called constant boiling mixture. So that is the azeotrope. Azeotropes are constant boiling mixtures. So what is the principle behind this azeotropic distillation? It mainly involves the addition of a new component, which is called entrainer, to the original feed mixture to form an azeotrope with one or more of the feed compounds. So if you are already we know that distillation is mainly based on the boiling point. If the boiling point of those liquids are very closer, then mostly we'll be taking extraction operation to separate those compounds. But this is one of the method. Azeotropic distillation is one of the method where the compound, the liquid mixture is having very less boiling point difference. In that case, we can go for this azeotropic distillation. So azeotrope is added. It is a third compound which is added to the liquid mixture, and it will form the constant boiling mixture. After that, this azeotrope can be removed either as a distillate or as a bottom. So entrainer, which is the third compound, or which we can call it as a solvent, is added to the mixture for generating a new lower boiling azeotrope. There are two types. One is minimum boiling azeotrope, or which can be called as a positive isotrope azeotrope, or new upper boiling azeotrope, which is called maximum boiling azeotrope, or negative azeotrope. So there are two types of azeotrope can be formed by the addition of this entrainer. Example, if for minimum boiling azeotrope or positive azeotrope, 95% of ethanol and 4.4% of water is present. And here the ethanol boils at 78.4 degrees Celsius and the water boils at 100 degrees Celsius. But when it becomes as an azeotrope, the azeotrope will boil at 78.2 degrees Celsius. And when considering the maximum boiling azeotrope, the hydrochloric acid, which is concentration of 20.2 degree, 20.2 percentage and 79.8 percentage, the HCl, the hydrochloric acid, will normally boils at 84 degrees Celsius, and the water, we know water boils at 100 degrees Celsius. But the azeotrope, when these two forms an azeotrope, the azeotrope will boil at 110 degrees Celsius. So the boiling point is increased. That's why we are calling it as maximum boiling azeotrope. So this is the construction of azeotropic distillation apparatus. So here the third compound will be A and B compounds are has to be separated. So for separating this A and B, the third compound azeotrope will be added to this to make it azeotropes and to separate it easily. Next is the method. So in distillation, how while designing the distillation apparatus, the number of plates, how many plates we have to be provide inside the distillation column is very much important. Number of trays, how many number, because based on that only the separation efficiency maybe will be calculated. So there are two methods which are used for determining these number of trays in the distillation column. One is McCabe method and another one is Panjan-Savret method, but mostly used method is McCabe method. So this McCabe approach is the graphical one and uses the vapor liquid equilibrium plot to determine the theoretical number of stages which is required for effective separation of the liquid mixture. So here the steps how to find out the number of trays in the column. There are steps which we have to follow for this. One is first step is we have to establish the plot. So we have to establish the plot and we have to add a 45-degree straight line and we have to draw the equilibrium curve with the given data and mark x of xb and xd. Xf is the mole fraction of feed and xb is mole fraction of bottoms and xd is the mole fraction of distillate on x-axis and draw the straight line from the x of xb and xd to get point A, B and C on the diagonal line. And then we have to find the intercept line by using the calculation I is equal to xd by r plus 1, where r is the reflex ratio which can be calculated from L by D value. L is the mass of the bottom and D is the mass of the distillate. And next we have to join that A and I point to get the operating line for enriching section. Next is we have to find the Q line. And for finding the Q line, we have to consider whether the feed is saturated liquid or saturated vapor. So there are different conditions are there to draw the Q line. So if the feed is saturated liquid, so just we are assuming that the feed is saturated liquid, then the Q value will be equal to 1. So we can draw the straight line from the point B to get the feed line. And we have to mark D where the feed line crosses the interceptor. And the point D is the point of intersection of operating line and we have to join the C and D to get operating for stripping section. Then we have to start drawing the steps between A and C. Starting from point A, the horizontal lines has to go up to the operating line for enriching section, horizontal line and vertical line up to operating line. It has to draw up to the operating line for intersection section. After the point of intersection, which is called where we are given point D, the vertical line should reach the operating line for stripping section. After crossing the point C, we have to stop constructing the step. Then we have to find out the number of trays by means of number of steps minus 1 is equal to number of trays. And the feed tray number can also be found out by means of where the feed line passes through the step. So this is the different Q line. If the Q line is cold liquid, then the Q is greater than 1. If the feed is saturated liquid, then the Q value will be equal to 1. And if we have to draw the straight line, straight vertical line, if the feed is saturated vapor, then the Q will be equal to 1. So based on this, we have to draw the Q line. So this is the general diagram, general plot, how we have to draw the plot for distillation process. So we have to draw the equilibrium curve. First, we have to draw the x and y axis, and we have to draw the diagonal line. Then using the equilibrium data which is given, by means of that, we have to draw this equilibrium curve, smooth curve we have to draw. Then after that, we have to start from the x up, we have to mark x up, xf, xb and xd, and that has to be, from that we have to draw the straight line. That straight line has to touch this diagonal, and we have to mark the point A, B and C. And after the writing marking the A, B, C, we have to draw the Q line from the feed line, and we have to see whether the Q line is whether the feed is saturated liquid, then the Q line will be straight line, or if the liquid is saturated vapor, then it will be horizontal line. And so we have to draw the horizontal line and the vertical line based on the feed line. Then after that, once we have to find out the point of intercept, and the point of intercept we have to find by means of xd by r plus 1, and that point of intercept has to draw from this d, this a by a point, and we have to join this a and I. After joining a and I, and this q line and the ai line where it intercepts, that point can be taken, and this point is D point, and that from that point we have to stop it. And next we have to stop constructing the steps, and this horizontal line has to touch the equilibrium line, and the vertical line should touch the operating line of the enrichment section. And once it crosses this D, then it has to move, it has to touch the operating line of the stripping section. So like that, we have to draw the steps, and after drawing the step, we can give the number 1, 2, 3, 4, 5, 6, like that we can give. And so here number of steps is the number of steps are 6 steps are present, and since the 6 steps are there, the number of trays can be calculated by from the formula where number of steps, number of trays equal to number of steps minus 1. And the feed line, here the feed line passes where we have to find where the feed line passes. It passes through the third tray. So the feed tray is 3, and the total number of trays are 5. So like that we can find out the number of trays for the particular distillation column.